Some more problems on based on buffer solution. So first question is calculate the pH of the buffer solution preparing by dissolving 30 gram of sodium carbonate in 500 ml of the aqueous solution containing 150 ml of 1 molar HCl, and K of this weak acid has been given. So first you write the equation. So this is sodium carbonate plus HCl. It will give you NaCl plus sodium bicarbonate. So on reaction this will give you. So milli equivalent you can first you find it for each cases. So here sodium carbonate is they have given here 30 ml of 30 gram they have given. So find it. So 30 by molar mass of sodium carbonate is 106. So this is and multiplied by 1000. This is 30 milli equivalent. And here HCl they have given here 150 ml. So multiplied 150 into 1 molarity. So in HCl this will be 0 and milli equivalent after reaction. So after reaction will be how much? So this is total is coming 283. So this will be your 150. So if you subtract 283 minus 153, so you will, if you subtract this, so here you will get 283 minus 150. So this is nothing but the 133. This will be 0 and this will be your 150 and this will be your 150. So 150 because this is the 150. Now we can put directly value because sodium carbonate and this sodium bicarbonate both will acting as a buffer. Why buffer? So because you can see here this is your salt and this is your weak base. So salt by weak base. So conjugate base by weak base. So we can write here pH is equal to minus log of A. Okay, so log of A plus log of carbonate. Okay, and minus bicarbonate. Okay, this is acting as a sort of acid. So mind you, this is a base. This is a acting as a acid. This is acid. Just keep in mind this is your acid base. So this is salt buffer. So this is acting as a buffer. So here you can put directly value. So minus pH is equal to, so pH is equal to, so this will be your log of, so here K of this acid is given here. This is acid acting as a, so this will be your log of 5.63 into 10 per minus 11 and plus log of 133. So this is your salt and this is your acid. So acid will be your how much? 150. So on solving we will get here 10.249 minus 0.52. So pH will be how much? So 10.197 is our pH. So this is our basically answer. So keep in mind this is our salt, this is our base. So this is acting as a base. So this is very important question. Okay. So AC base plus acid. This active plus this is acting as a proper base. 15.15 molar pyridinium chloride has been added into a 500 centimeter of 0.2 molarity of pyridine solutions. Calculate pH and hydroxyl ion in the resulting solution assuming no change in volume. Kb of pyridine is 1.5 into 10 per minus 9 molarity. So again we have to use the same formula. So this is a base formula. So we will take the basic buffer formula. So basic buffer is POH is equal to minus log of Kb, or you can use a pKb plus log of conjugate acid by base. So for basic buffer is a formula basic buffer. So again we can write here, so log of Kb, this base has been given, so this is nothing but the, you can write here minus log of 1.5 into 10 per minus 9, and again plus log we have to find the conjugate acid. So conjugate acid is nothing but the pyridium chloride. So pyridium chloride, so we can write here conjugate acid is how much? So this will be your 0.15. So this is a 0.15 and divided by 500 into 1000. Okay, so 0.15 is the mole given, so mole by volume, so answer will be your 0.3. So you can put here directly here 0.3, and base is given here how much? So base is given pyridine is 0.2 molarity. So volume is same, so you can volume you can see write the mole value only. This is the mole and volume is again it's 0.2. So we know this pen. So what is the pOH? So pOH we can find out. So we know this value, so on solving we will get here answer is 9. Okay, so answer will be your 9. So again pOH, so concentration of OH will be how much? 10 to the power minus 9, and concentration of H plus will be how much? 10 per minus 5. So pH will be your 5. So this is our answer. calculate the mass of ammonium sulfate in gram which must be added to 500 ml of 0.2 molarity ammonia to yield a solution of pH equal to 9.35 and Kb they have given. So again this is your basic buffer. So basic buffer formula we know very well. So POH is equal to minus log of Kb plus log of conjugate acid by conjugate acid by, or we can write here salt by base. We can anything. This is base, or we can write here conjugate bases. You can write here salt by base. So both we can write here. So upper value will be salt. So first we have to find the salt is ammonium sulfate. So what is the value? So for ammonium sulfate we can see here. So what is the concentration of ammonia? So what is concentration of ammonia? Here you have to take here value. Suppose A. So A is the mole. So if you write here concentration, this become A is the, suppose mole is there. So write here A by 500. Volume is given 500, and concentration of ammonium hydroxide, because this is the reaction it will give you ammonium sulfate will be ammonium hydroxide. So ammonium hydroxide will be how much? Ammonium hydroxide will be, so 0.2 into 500. So we can write here 0.2 into 500. So this will give you 100. So this is the ammonium hydroxide in water. So here we will get log, this one is given, so minus log value is how much? The log value is given 1.78. so minus log of 1.78 into 10 power minus 5 plus log of, so here volume is same only, so we have to take only mole. So take A value and 100 value, so write here A divided by 100 because volume is same. If you write here 500, no problem, write here 500, this will be ultimately cancelled. So again pH is given, so pH is nothing but the 14 minus 9.35, and this will log value, this log value is nothing but the 0.4796, and this will be ultimately plus log of A upon 100. So every value is given, so we can find out. So here, so A is equal to nothing but the 79.51. So this is the moles of salt. So moles of salt means this is the millimole. I think this will be your millimole. Okay, so again millimole of ammonium sulfate added, so millimole of ammonium sulfate added will be how much? So this will be added by A by 2 because the N factor is 2, so we can write here, so 79 plus 41 by 2, so this will be your 39.755. and again weight we know that the weight of ammonium sulfate is, molar mass is your 132, so if you divide by 1000, so this is equal to nothing but the this mole. So weight is, this is the mole into the millimole, so here this is nothing but the millimole. Okay, and millimole means weight into 1000 will be your millimole. So again this is nothing but 3.39.755. so on solving, weight of ammonium sulfate will be equal to 5.248 grams. So this is our answer. So how many mole of HCl will be required to prepare 1 liter of buffer solution containing sodium cyanide in HCl of pH 8.5 using 0.01 gram formula mass of NaCN. So here we can note down, so 0.01 gram formula mass means 0.1 mole. So this is nothing but the 0.1 mole. So write the equation. So NaCN plus HCl, it will give you what equation? NaCl plus HCl. Okay, so here how much mole is added? So mole you can write here, so 0.01 mole. So this is given here, formula mass 0.01 gram. So formula mass means divided by molar mass. So this is nothing but the moles. More, and again here we just take A, so this will be initially will be 0, so moles after the reaction with the base and the HCl, so here they will give you A mole, and this will be 0, and this will be your 0.01 minus A. So now we can write the buffer. This will become buffer of this one. So buffer is NaCN plus HCN will act as a buffer. This will be act as a buffer. So this buffer is your acidic buffer. So as to use the formula of acidic buffer, so pH is equal to minus log of Ka, again log of here, so conjugate base by AC. So conjugate base is how much? This is a conjugate base. So conjugate base is 0.001 minus A and divided by A. So again we have every value is here. So value of acid is given here 8.5. So 8.5. So minus log of, so Ka value they have given here. So 4.1 into 10 to the power minus 10 and plus log of 0.01 minus A divided by A. So every value is given, so answer A will be your 8.85 into 10 power minus 3. So this is your mole of HCl because volume is same. So this is our answer. Acid HA after treatment with 12 ml of 0.1 molarity strong base BOH has a pH of 5. At the end point, the volume of same base required to 26.6 ml. So here weak acid, so their base is given 12 ml, 0.01 ml. So after the reaction endpoint, what happens? The volume of the acid is equal to the volume of the base. So volume of the base is given, volume again, this will tell you the milli equivalent of acid. So first you write milli equivalent of acid is equal to milli equivalent of base. So already we know that. So here milli equivalent acid is what? This is equal to this. From here milli equivalent of base. So from what is the milli equivalent base? The milli equivalent base they have given here. So milli equivalent of acid we can write here 26 into 0.1 molarity. So this is nothing but the 2.66 milli equivalent. Now for the neutralization of acid, partial neutralization of acid. So partial neutralization acid will be HA plus BO. It will give you BA plus water. So we can write here milli equivalent before reaction. So this is the milli equivalent of acid is nothing but the 2.66 and milli equivalent of BOH is how much? 12 into 0.1. The 12 into 0.1 mole is nothing but the 1.2 and this will be 0, this will be 0. So milli equivalent after reaction, so after reaction will be 2.66 minus 1.2, so 2.66 minus 1.2, this will give you 1.46 and this becomes 0 and this will becomes 1.2 and 1.4. Now this will act as a buffer, so HA and BA will be buffer. This will be your buffer solution, HD buffer. So put the formula of HD buffer, pH is equal to minus log of Ka plus log of conjugate base, so conjugate base by acid. So this is the formula of HD buffer. So directly put value, so pH is given here 5 and here minus log Ka that we don't know, but we know the so conjugate base of buffer. So conjugate buffer is here 1.2. This one salt is given, base is given and acid is given 1.46. So on solving we'll get here Ka value is 8.219 into 10 power minus 6. So this is the dissociation constant of the acid. Solution of weak acid was titrated with base NaOH. The equivalence point was reached when 36.12 ml of 0.1 molarity sodium hydroxide had been added. Now 18.06 ml of 0.1 molarity were added to titrated solutions. The pH was found to be 4.92. So what is the K of acid? Dissociation constant of acid they are asking. So we have to find we know the acid base reaction. So for complete neutralization, so we have to write the neutralization. So write the reaction. So milli equivalent of acid is equal to milli equivalent of base, milli equivalent of so NaOH. Okay, so this is nothing but the 36.12 into 0.1. So here you will get 3.612. This is the milli equivalent of acid and base. So write formula HA plus sodium hydroxide, it will give you Na plus water. So here the formula is 3.612 and here they have given base 3.612. So definitely this will be your 0 and this will be 0 and after this reaction this becomes 0, this becomes 0 and this becomes 3.612 and this becomes 3.612. So now here, so what we are adding 18.06 ml of HCl we are adding, okay, to the base. So here we can see here after addition of HCl, which is nothing but the 18.06 and 0.1 molarity. So this will add it to titrate the solution. So milli equivalent of, we can write here milli equivalent of sodium A will be how much? It is nothing but this much. So 18.06 into 0.1 molarity. So this will give you, so this will give you here 1.806 of sodium. This is NaA. So this is salt they will give you. Acid salt will be this much is the concentration because this is a titration salt. So we can again write here reactions this plus. So again we can write here equations. So again sodium NaA and plus reacting with the HCl. Okay, so this will give you your NaCl plus HA. So this will now act as a buffer. This is the acid but this will be act as a buffer. How buffer? So this is the nothing but the sodium acetate is previously how much? So 3.612, and here HCl was how much? HCl was 1.806. so again this will react with this one. So after reacting, this will be left. So mean equipment after reaction, so 3.6 minus 12 1.06, so this will become how much? 1.806, and this will be your 0, and this will be your, initially it was 0, so this will be your 1.806, this will be also 1.806. so now this will act as a buffer. So Na and A act as a buffer. This buffer is your acidic buffer, so we apply the formula of acidic. So pH is equal to minus log of Ka plus log of conjugate base by acid. Okay, so if we put here value of K we don't know, pH is nothing but the 4.92, it is given here. So this is equal to minus log of Ka, and log of conjugate base is how much? Log of conjugate base is here right here, plus log of 1.806 divided by 1.806. so this is nothing but the 1. So again we can solve it. So here Ka value will be your 1.2 into 10 to the power minus 5. so this is our answer. 20 ml of 0.2 molarity NaOH are added to 50 ml of 0.2 molarity acetic acid. So here acid is given, base is given. So definitely this reaction will give you sodium acetate plus water. So sodium acetate plus water is the salt plus water. So first you write what is the pH of the solution. So very easy. So write here NaOH plus CH3 COH. So this will give you CH3 COONA plus water. So this is the acid base reaction. So here how much is sodium hydroxide? So definitely we have to find the volume. Sodium hydroxide they are given here. So 20 into 0.2. So this will be nothing 4. So this will be a millimole. First we write millimole because here ml is this, we will get millimole. And acetic acid is how much? So 50 into 0.2. So again here given here. So this will be again here. So 10. So again initially this will be 0, this will be 0, and after reaction what will be the millimole? So after this millimole will be 10, so this will be 0, this will be 6, and this will be your 4 and 4. So now we can see what is the molarity of acetic acid. So molarity of acetic acid will be your acetic acid will be how much? So this will be your 6 by 70. So why 70? Because this is given here 50 plus 20. This is 20 plus 50, this will become 70. Okay, so again concentration of sodium acetate will be how much? Concentration of sodium acetate will be so nothing but the 4 upon 70. So volume is case in this case, so we will take only mole value. So now this will becomes your acidic buffer. So we know the formula of acidic buffer, pH is equal to pKa plus log of concentration of salt by acid, and we know the salt, we know the formula of acid. So pH will be how much? So pH will be your, we have to find the pKa. So pKa is given here, so the log of something given here. The log of something means 1.8 into 10 to the power minus 5. So put here value 1.8 into 10 to the power minus 5, and plus log of salt value we know that is 4. So 4 by 70 divided by 6 upon 70. So 70 will cancel. So we will get this for you. Now after solving we will get here pH is equal to how much? 4.56 into 86. So this is our answers. The composition of the HD buffer solution made up of HA and sodium. Salt, some salt is there of total molarity 0.29, having pH equal to 4.4 K. So here K given, pH given. So we have to find the composition of HD buffer. So one we have to take, other we have to take some B or something like that. So just write down pH is equal to minus log of K for acetic buffer plus log of concentration of conjugate base divided by concentration of acid. So on solving we'll get here. So here we know that pH is how much? 4.4, and log K, so log K will be your 1.8 into 10 to the power minus 5 plus log of conjugate base. What is the concentration of conjugate base? So if you take the concentration of conjugate base is like suppose A, so what will be the concentration of acid? So acid will be your, the total given here 29 molar is total molarity, so it will be your 0.29 minus A. So this is the total molarity of acid. Now put this 2 value over here. This is the A, this is your 22 minus A. Total molarity A is there. So on solving, so now we need to solve this one equation. So this is the again mathematical equation. So on solving here A will get 0.09. So this is the moles. Now concentration of salt will be how much? So concentration of salt will be 0.09 molarity, and concentration of acid will be so definitely 0.29 9 minus 0.09, so it will be your 0.2 molarity. So all problems are based on the formula, so we have to find the conjugate base acid like this value, and we can solve any type of problem based on this.